wrote my lab on report for you guys at the book.
So, I have a policy where like I'll finish my homework and then I wait like at least 24 hours before turning it in so that I can like go through and like I have a rule that I gotta sleep on it before I turn it in because I'm gonna wake up in the morning and be like, oh crap.
That thing.
Yeah, because if I turn it in last minute, like if I turn it in like when it's actually due, I'll wake up like the next morning when I can't fix the problem and be like, so I did this, and this wrong. And it's always like this.
All right, for those that are online, can you guys hear and see the screen okay?
Oh, I'm a professional in writing email.
The source for officials is just
Okay, great. Let's see. Okay. All right, so exam 2. Same time as class. And it will be in the Ingman lab upstairs again. So Web L210, called the Ingman lab. For those that want to do it online, make sure to contact me for unique link. So do let me know if you do plan to do it remotely. Otherwise, same format as last time. It will be on the computer Canvas quiz. You'll want to have on the window, you need to show for both online and in person, all of the tiles of each of your tabs so that everything is seen on one screen. You're welcome to use multiple computers if you want to have a computer and then use your screen to have other things up there. You're welcome to bring your own computer and use your own computer. Scripts, if you use scripts again or any coding, make sure that you take your snippets of it and include it in your submission of your work. Yes?
I had a question on the group exam problems.
Yes.
Could you, I feel like I don't understand the difference between the two types of problems you're asking for.
Okay.
Could you like go over some of the clarification between them?
Yes, so tonight is due your group, tomorrow is due your group work. And on there, I want 3 problems. And pretty much it can be either the steps up to the final way of solving a S-domain circuit problem. So the first one was kind of like, do some of the steps to it. And then the last one was 2 of the ones where you go all the way through all of the steps. So you're welcome, though, to have at least one of going through the whole steps and then parts of the other ones. Does that help clarify? Okay, so 3 problems, partial steps in them, and at least one that goes through the whole steps of from start to finish.
So when you say partial steps, is that the partial fractions?
Uh-huh. Yeah, so partial fraction expansion, or if you want to just translate into the S-domain, have the S-domain equation and translate, well, that's the partial fraction, is to translate back into the time domain. Yeah, so any of those steps, just writing the S-domain equation from a circuit. So whatever is going to help you is basically what I want you to get out of it, is that, let me practice more of this type of a problem. So that if that is going through from beginning to end of problems, doing 3 of those is great, because that will help you a lot. And if you're having trouble creating problems, you're welcome to use search online, find problems that already have some solutions. Just make sure you're finding them and then going through the solution so that it's helping you. Okay. All right, any other questions? Did that help, Carly?
Yes, thank
Okay.
Yeah, so you have to join.
All right. Did we already do this one? Okay. This one. All right, last time we went through, I think it was this problem. Yeah, it was this problem and kind of had a rush at the end. Is there any questions? This was, go up to this one. This was this problem.
We did this on Friday.
Sorry. No, I was like, I swore I had it here, but, yeah, we did this one Friday, correct? Or was this not the one we did Friday?
Yes.
Okay. Yep, so this was the one we did last Friday, and I had translated it to the Thevenin to solve for it, but there was other ways you could set it up to have two equations for Vx2, Vx1, and then also solve it to get to that. And this was using Wolfram. I set up the equation and then used Wolfram. So I would encourage you guys to use both, like you can do it by hand, but also use Wolfram to like check, or use another calculator to check your work. Just there's lots of opportunities for math errors here. So
So every time we get the nasty fractions over fractions under fractions, we just go Wolfram.
yeah, but make sure to be very careful in Wolfram that like your equation, like I typed this in and then I looked up and I was comparing the two and I was like, oh, that's not the same. So do make sure that you're checking like you are getting the
Right.
same equations in there.
And then we just add snippets like that. for the
Uh-huh.
beginning.
Yeah, so this would be what you would add. You still have to do, like the next step, which would be finding the fraction, factorizing that, so. So feel free to include snippets like this, and then like I did the factor, had the snippet of that, so I didn't have to do the quadratic formula.
If we write out our whole like Vx equation or VA equation, do we have to put a snippet of the Wolfram? Or could we say like, here's my equation, here's what Wolfram gave me?
I would include what Wolfram is in case you made an error.
Okay.
So if you can, take a snippet of it, or if there's some other calculator you're using, I would try and take a snippet of it. If it's your handheld calculator, you won't be able to, but I guess you could. You could still take a screenshot of it just to make sure that the error is not,
Okay.
or at least knowing where the error is that you typed it or not. It just helps for that. Okay, so then all right, so any questions though about the steps from this problem? Okay, you guys good to, I guess I should ask what kind of, maybe let's start with this one. This will go through all the steps. Okay, so let's work on this one.
We have that current that's
Yeah,
going
you
through the
gotta-
two parallel resistors. And so that's gonna have to be, yeah, that's gonna end up being 2 ohms total in parallel that it's going through, and that's a parallel with the capacitor, so that's gonna have the same voltage as the capacitor, which means that it's gonna be 1 amp times 2 ohms or 2 volts.
Marley, you missed this. To show you that one. It's Kirkwood. Spot. It was fun. It was really fun. My husband had to convince me to go off it though. So he went first and then he's like, "You can do it." I was like, "Okay." All right, so where to start with this? To solve this kind of a problem, where are you gonna start? Yes.
Find initial and final values.
Okay, so initial value.
Okay, initial.
And then the final will be, this final circle will be what you'll need to derive all the equations up from. So, good job. So first find initial conditions. So to do that, what do you need to do?
Draw the circuit.
Okay, so do t equals 0 minus, and then determine the values for each one. So, oops. You look at where the switch is gonna be. So at 0 minus, where's the switch gonna be? So it'll be an open, so I just kind of removed it there. Inductor, sorry, I should have done. Inductor will be what? Short. And then the capacitor, open. And then what will be the value for the source? 1, correct. So we just use 1 there.
One?
1 amp.
Oh, wait.
1 amp, yeah,
Okay.
1 amp. Okay, so then we're gonna analyze this circuit. So what will IL of 0 minus be here?
0.5.
Okay. And if you don't know that, you can do node voltage here. So you could set Vx and do -1 plus Vx over 4 plus Vx over 4. And find Vx. And then IL will be Vx over 4 for 1/2. Okay, so you could do it, solve for it. If you don't see, if you understand the concept of current dividers, you can see that this is a current divider with equal resistance in both branch. So it's going to divide equally. So it would be half of the value. So 0.5 that way. Either way you see it, VC 0 minus
Well, isn't V equals IR, so 2.5 times 1?
1 times 4.
No.
no, it would be a half times 4.
Oh.
So the current going into it, they split equally. Or you can do, again, the math and note that Vx is equal to Vc. If you don't see it. So mathematically, just do the Vx or the node voltage equation there. Do you see it now, Ian? Okay. All right, any other questions on that? Okay, so now we have our initial values, and now we need to redraw the circuit for our initial values. So redrawing the circuit, the switch will be closed, which means what happens to R?
It gets shorted.
Okay, so I could just redraw it with a short here. Let me start with the source. What will the source value be? Correct, 1 over S. What will the inductor value be? So you can either write 0.1 milli or 0.0001. I'm going to write 1 milli S. R was 4, I think. And then what do you do with the capacitor?
It's 1 over SC.
Okay, and 1 over 1 micro S. And then what else do we need to include here? The sources. So I brought these down to make sure the polarity goes in the right direction. So do review which polarity they move. So we found IL to go down, so it is going to go in parallel and have the value of 0.5 over S. And then in parallel with this, it will go up because VC was found as plus to minus. And the value of C, which was 1 micro, and VC was 2.
Is it 0.5 or is it 0.05 milli? Because isn't it times the initial, or is that just with voltage?
So wait, what?
Sorry, let me look at it.
Okay, so IL 0 minus was 0.5. So you take the value of IL 0 minus over S.
Okay, no, I was just confused, because when you do it with a voltage source, you have to multiply it by L, but you don't with a current source.
Correct. So just, yeah, look at that diagram to just make sure that the values are correct.
That's a 2, not an S,
That is a 2.
right?
2 micro, maybe I'll rewrite that. 2 micro. Okay. All right, questions about getting this circuit? Okay, I'll give you guys a minute to kind of work through the equation set to then, you're trying to find V of t. Is what your end goal is. So I'll give you guys a minute to work through that, and I'm gonna use Wolfram to get an equation set.
like once I'm at this point with finding Vx, I did all of these going out, and I had V of t is Vx times Us, right?
V of t is gonna be Vx.
It doesn't
Right.
have anything to do with impedance
No, because it's the voltage between the top, which is all the same node up here,
in the bottom.
and the bottom, which is the same as Vx.
Oh, okay. So it's not times. So.
So the current going through there would be Vx
Oh yeah, that's what I'm thinking.
times mu x.
Okay. Okay. So then it's.
'Cause it'd be
it's
1
just
over
Vx.
the- yeah.
I just have to solve this.
Yeah. So Vx will be Vt.
Vx will be okay.
Vt. It's not. Okay, setup of the equation set. So if I call this Vx, what's my equation set gonna look like?
What's your node voltage?
Yeah. So this one,
It's gonna be
One over S.
this one,
The X over the 1 below times S.
and this one,
Plus, just the 0.5 over S. V X over 4. And Vx over, or Vx times.
either way.
Yeah.
So you could either write it as Vx over 1 micro s or Vx times 1 micro s. And the last one,
Negative.
so that is my equation. And then I used Wolfram. So there's my snippet of Wolfram. And I just verified that those equations are the same. So I used that z was equal to s and that Vx, I used x. So I have minus 1 over z plus x over 0.1 milli z plus 0.5 over s plus x over 4 plus x over 1 micro s, or z, minus 2 micro. So that equation is the same, and then I end up with this as my equation. And then I need to factor the bottom. So again, I used, Wolfram to factor the bottom. So I factor that. Oh, I didn't catch the whole snippet. Okay. So capturing that. Oh no. Okay. Okay, so that gives me 200K and 50K. Yes.
Numerator, you have a 2 times s plus 250k. Where did the 2 come from? Trying to see if I missed
Go to my old notes. So these are the, so if you didn't want to use Wolfram and you just do it by hand, let's see. You combine all the VXs together. Oh, sorry. What happened to my OBS? There we go. Okay, sorry. Okay, so combine all the VXs together, and then you take over to the other side all of the constants. Get a common denominator. So on the right side, I got a common denominator of 2s. And then
Oh, what's the last number? It's kind of, no, scroll back up. Minus 2c. C just.
C is 1 micro. Oops. Oops.
This is when you solved it without Wolfram?
Yeah. So that's C is 1 micro. So you got this equation?
So.
So once you get,
Okay, I think I multiplied mine out. Because I had 2 over 0.1 milli plus 2 plus s over 2 plus 2 micro times s squared. So I just left it in the denominator instead of bringing it up to the numerator. Actually, no, that still doesn't explain anything.
if you want, I can look at your work after. Because yeah, looking at this, you should end up with an S in the top. And then that 4 micro gets divided by 2 micro for a value of 2. Okay, so there's I'll have those in the notes as far as the worked out hand calculations, and if not, then the Wolfram will be there. So either way, you should end up with the same equation. Okay, so from here, you end up with, you have to note that Vx is the same as Vt. So this node up here, Vx is the same as Vt, or V, and so you then end up with Vx is 2 times s plus 25,000, or 250,000 over s plus 200,000, s plus 50,000. Okay. Go ahead and take a minute to make sure that you can translate this back into, so this is Vx of s. So take a minute to
Get this into the right
time,
routine.
yep, time domain.
Let me know what you guys get for A and B, cause I'm not
So,
sure.
what's the factor, should we do?
Huh?
I made it 2/3, so you have 8 over 3.
That's what I got.
So
8 over 3, okay, so you got A is 2.666, yeah, B is negative 0.666.
Yeah.
Cool. I got it right, you guys aren't all that special.
Wait, I got my sign mixed up.
Actually, we're all special.
We could just say we're all special, no need to put us all.
Yeah, just
Yeah,
You're right, maybe I'm just as special.
Yeah, you're just as special.
We're all.
I'm definitely not yours.
And then you treat it just the same, you just put in S as like -200,000.
I got my.
And that's just
No, I got those, but my signs are mixed up. I don't know.
It just happened.
Yo, I don't,
Well, Wolfram gave me negative instead of or positive. Did I do the current wrong?
wait,
Check the input, what the input?
yeah, wait, let me see.
Well, it just, when you define your occurrences, go to the which is like what you want.
Yeah, didn't you do your currents the other way?
Which way did I do my currents?
So you do yours as
I did positive one over S.
What?
So you did them the opposite way, so that should be fine.
Just say you did it
But-
the opposite
Just
way,
depends
if you
on
got
how
the
you
right
set up
answer,
your
just
race.
negative.
Yeah, but then it's giving me the wrong signs for the. Wait, but then I have to make sure everything else is minus, right? Current ones then are minus.
Yeah, I can work with that.
Is that easier?
As far as current direction, it doesn't really matter which one you do.
As long as you just keep it straight.
Yeah.
This is A minus, this was a plus, right? And then
Did you
this
get
is-
negative? You knew? Alright, I was worried because I didn't find out for me.
Because I did it the other way.
I'm still trying to use you.
This one should be minus, right?
That's the, that.
Yeah.
Yeah, that one.
So I'm just gonna do.
Some of the other students, and I had somebody else look it up.
Just realize.
I don't know, working for some reason.
That should be. Right?
Yeah. It just gave me. I plugged it in wrong, but I got the answers.
Yes.
I just have one fraction.
Wolfram can actually just do it.
You can-
Yeah, well, very just got
It's
it.
better to do it.
Like, all the hard parts of this, like, if you have Wolfram, this is basically just a regular, like, this feels like.
Scientific notation and test, so it can't be as certain, but.
Although I tried to do something complex one over.
Okay, so you can, so doing partial fraction expansion, I had a couple comments because you have an S in that numerator is throwing off some people. So even if you have a full, like, polynomial in the top, you still do the same steps for that partial fraction expansion. Yes?
Well, in the rare case, sometimes that polynomial would be higher order and then you have to do long division, right? And then,
Yeah.
but then you'd end up with a polynomial, out in the front, which would be like delta functions and weird things like that.
Yes.
I could see that happening from current through a capacitor, but would we ever expect to see that, or?
Typically, no, you're gonna use, no. So, yes, it will be a lower order polynomial than what will be on the denominator. So don't have to worry about that case, Adam, but thank you for bringing that up. So don't get thrown off, though, by that S in the numerator. So even if it's an S squared in the numerator, don't get thrown off by that. You treat it just the same. You would set it up as A over the first fraction plus B over the second fraction, multiply both sides. And so you should end up with the variable above the 50K should be 8/3, and the variable above the B, or the 200K should be minus 2/3. And then translating that back gives you this V of t. You can use Wolfram to check your answer. So that would be 8/3 e to the minus 50K, which is right, and then a minus 2/3 e to the minus 200K. So that is the same.
You should do one just like this on the test.
Yeah, no,
This
just
one was-
change up the
This one was good.
variables.
This one was a straightforward
It's
one.
like
Okay.
0.1 farads instead of 0.1.
You can do whatever you want.
All right, so questions about these steps? So I didn't quite get over all of the problems that were on here, so I'm gonna post solutions for also what we didn't go over, if you guys wanna use a few other extra example problems. They'll be on these notes, and then I'll go back to last week's and fill in whatever wasn't there too. So, all right. Okay, see you guys on Wednesday. What? The lab?
In the computer lab.
Yes, upstairs in 210.
How to do it, and then I just went, I was scrolling through